for the function below, use the second derivative to find where the function is concave up, concave down, and find the inflection points. So this is a rational function, and we had previously differentiated this function. Um, so we have the first derivative. I had already calculated that in the previous videos. But anyway, the first step is to find the first and the second derivative. So step one, find the first and the second derivative. Now, the first derivative for this function is, I had calculated this in the previous video, and it's 6x over x squared minus 1 squared. So this was calculated in previous video. So it's one of the previous videos. I had already calculated that. So I'll just go ahead to and work out the second derivative from this first derivative. So we know that, and we are going to apply quotient rule to find the second derivative. So apply quotient rule. To find the second derivative. So this the quotient rule states that if y is equals to u over v, then dy over dx, or the first derivative or the derivative, is equal to v du over dx minus, let's write this properly. So v du over dx minus u dv over dx over v squared. Okay, so this was in the it's in your formula booklet. You don't have to memorize it. Okay, you just need to know how to use it. Now we are going to apply this in this, assuming that this is equal to u over v. Okay, u over v. Then we can apply that to find the second derivative. So that will be my next step. So my next step is to find the second derivative, which means I need that function. So the second derivative will be just need to write it below here. So I'll start with v, which is x squared minus 1 squared, d over dx of 6x minus 6x d over dx of x squared minus 1 squared. Okay, so I need to find the derivative of that. And by the way, all this over v squared, which is x squared minus 1 squared squared. Okay, so we need to simplify this, which means we shall end up with x squared minus 1 squared multiplied by 6 minus 6x into chain rule, outside inside, so 2 into x squared minus 1 multiplied by 2x, all this over x squared minus 1 to power 4. If you simplify this, you will end up with actually what I'm going to do here, make my work easier, is to factorize out x squared minus 1. Okay, we can take out x squared minus 1, which means I'll end up with x squared, I shall end up with x squared minus 1 into bracket x squared minus 1 multiplied by 6 minus 6x and multiplied by 2 is left and 2x is left. Okay, all this over x squared minus 1 to power 4. Now this will cancel with that, so I'll have x squared minus 1 to the power of 3, which means my new expression will be just need more space, so stamp the page. Okay, so what I'll end up with is I can FOIL the numerator, so 6x squared minus 6 minus 24 x squared over x squared minus 1 cubed, which will be equal to minus 6 minus 18 x squared over x squared minus 1 to power 3. Okay, so that's what we end up with as our second derivative. So what will be the next step after that? The next step after that will be that was step 1, first and second derivative, we have them. So step 2, we shall be setting the second derivative equal to 0 and solving for the potential point of inflection. So step 2, set the second derivative equal to 0 and solve for potential point of inflection. So our second derivative here is negative 6 minus 18x squared over x squared minus 1 cubed. If we equate that to 0 and we multiply the denominator by 0, that means we'll have negative 6 minus 18x squared is equals to 0, which means that we'll end up with negative 18x squared is equals to 6. X squared will be 6 over negative 18, and x will be the square root of a negative, which is not a good thing. So what does that mean? It means that we don't have inflection points. Okay, so that means no inflection points. So we don't have any inflection points. So we have to go back to the question. All right, what else is the question asking? The question is asking to find inflection points. None. Okay, but it's also asking us to find where the function is concave up and where it's concave down. We can do that. We can do that. Why? Because we can also find the critical points of this function. So which leads us to step 3. So step 3 will be finding other critical points. And when I say other critical points, I mean the vertical asymptotes. So step 3, find other critical points Let's just call them asymptotes. Okay. And here we're talking about vertical asymptotes, just to be specific. Okay, so these are vertical asymptotes because they are x values, vertical asymptotes. So the vertical asymptotes can be found by just equating the denominator to 0. So if we equate the denominator to 0, we'll have x squared minus 1 is equals to 0. Okay? So we shall have x squared minus 1 is equals to 0. I'm just writing this down because previously students have asked, so how do you find the vertical asymptotes? All right. So you equate them to the denominator to 0 and you solve for x. Okay, so we have that, which means that is just a bracket. It's nothing fancy here. So what you're going to do is solve for this. So difference of two squares. So x plus 1, x minus 1 is equals to 0, which means x is equals to negative 1 or x is equals to 1. So we have two critical points, and we can draw a sign diagram and investigate whether the graph is concave up or concave down on either side of these asymptotes. So that leads us to step 4. Okay, so step 4. Use the sign diagram for the second derivative to find where the function is concave up or concave down. So use the sign diagram for the second derivative to find where the function so which means we need to draw a sign diagram and find where the function is concave up or concave down. So what that means is we have something like that, and our critical values are x is equal to 1 or x equals to negative 1. So these are x values, and we have x is equals to negative 1 and 1. But what I'm interested in is the sign of the second derivative, which means I'll pick some test points. So to the left of negative 1 could be negative 2. Here I can plug in 0. And here I can plug in something like 2. Now if you plug this into the second derivative, this guy here, so what you shall end up with is negative 2, that will be negative 26 over 9. You can just use your calculator, that will be 6, and that will be negative 26 over 9. And you can see that this is negative, this is positive, this is negative. And we said that a function is concave up when the second derivative is positive, and concave down when the second derivative is negative. So you can go ahead and write this down. So you can say that this particular function is, may need that. Okay, so we can say it's concave up when the second derivative is greater than 0. And when is it greater than 0? when x is between -1 and 1. Concave down when the second derivative is less than 0, and that will be when x is less than -1 and when x is greater than 1. Okay?